In the previous episode, Claire and Mary explored an applet that let them transform the sine function. In this episode, they will use the applet to create a model of the average maximum temperature in Houghton using averages from 1961 to 1990. To do this, they will use the following data. The data show the average maximum temperature for each month of the year. The students will use the applet to create a function whose input is the months and whose output is the average maximum temperature. The 12 data points have already been plotted for them. They will now use the applet to fit a function to these data points.
Well, let's see.
We have to find the minimum.
The minimum.
Average minimum temperature for January 7.8.
It's, yeah.
Would that be K? Try changing that one.
Ooh.
Oh.
Well, let's give it some time. So the lowest we can go is like 7.5.
That's 7.8.
Well, we can't go to 7.8.
Oh.
We can only go to 7.5.
Okay.
So it'll be close enough. And then A, we said A was the distance from the middle to like the bottom.
The other thing we need
So-
is average total precipitation. Oh, wait.
This is just the maximum temperatures. We don't need to
Why
focus on
don't-
that right now.
Yeah.
Yeah. Oops. Let's try something. 20. Woo! No. Okay. H. I don't know what we do with H. Wait. Hold on.
What was the one that made them like squigglier, like closer together? I wonder if we could use that to get our minimum temperature.
12.
Okay.
You do a full rotation every 12 because there's 12 months.
Yeah. Oh, yeah.
Yeah. Okay. And then H. Yeah, so that's fine.
That looks
Because
good.
this is like it's going back to December, this one right here.
Yeah.
So that makes sense to me.
So this is January. We modeled January.
And they said,
Where do you see the month of January?
Right here.
no, January is this one right here. Just that point.
Oh, just the point.
Yeah.
Oh, I thought it was like the whole thing.
Hold on. And that K is the annual, approximately the annual. We can't get exactly 48.1 on there, but 48.1 is the annual, which I don't know what that means, but
The annual average? Is that what it
Average.
Oh,
says?
Yeah.
average.
I think it's probably the annual average.
Okay.
okay, yeah.
So what would that mean in terms of our temperature if K is like the 48 and that's our annual average? So like on average, if we were to average all of the months,
Our average degrees?
our average degrees here
Yeah.
would average out to like 48.
Mm-hmm.
And what does the A represent, that 27?
The A is like, what did we say A was before? It was
I
like
can't remember.
the height from like,
Is it in our notes still?
the height from the middle.
Oh, okay.
Oh, wait. Oh, yeah, I guess that would kind of make sense because if, like, 27,
If what? What are you thinking?
27 times 2.
Is 54.
54, which is like, I'm like, I don't, I'm
Which is 6 above 48.1.
27.
What are you thinking right now? You're saying it's 50 or 27, and 27 times 2 is 54.
27 is like our height above like 0. Like from like if Like,
Okay.
not height. Sorry, scratch that. But like 27 degrees above zero.
27 degrees above zero. Could
Yeah.
you find the, I'm curious if this might help. I'm wondering if you could look at the maximum and then compare it to the minimum temperature here.
So our highest temperature was in July, and that was 75.4.
Mm-hmm.
July. And our coldest was January,
Mm-hmm.
which was 20.4.
Mm-hmm.
And so if you do 75.4 minus 20.4 equals 55. And then 27 plus 27 equals 54, which is super similar to 55. So that is half of the average,
Approximately, yeah.
about. So equals about 1/2 of the average of the
Of the average, just say.
of
Of
the-
the difference between the max and min.
difference. Okay.
Half of the difference between max and min.
The students used the applet to create a function that modeled the temperature data. After using trial and error, adjusting the sliders as needed to find this function, they made sense of some of the numbers they had found. For example, they found that A should be 27 because that was about half the difference between the average maximum temperature in July, the hottest month, and the average maximum temperature in January, the coldest month. They also noted that K being 48 made sense, since this is about the annual average temperature. In the next episode, they will create a similar function, but this time they will create a model based on data from 1981 to 2010.